Don't forget to subscribe to our YouTube channel at youtube.com/ADSR This series of videos will cover all of the features in Kontakt. We'll continue with effects. Now, we'll go over each of the effect modules as well as their parameters. In Kontakt, effects are modules that alter dynamics such as compressors, as well as modules that change the signal in a nonlinear way such as reverbs. These modules can be accessed by dragging them from the Modules tab of the browser into an effects slot or by clicking on the plus icon in the lower right corner of an effects slot, which opens up a drop-down menu which shows all available effects. When talking about these effects, I'll only mention controls unique to the module. Controls that are used in all of them, like output or standard compressor controls, will be skipped. Alright, let's start with the transient master. The transient master is a compressor used to control the attack and sustain of a sound. It works best on sounds with fast attacks such as drums. Smooth. Transient master works best with drums, so certain input signals such as an acoustic guitar might not work well with transient master. Enable this button if you encounter any problems. Sustain controls the scaling of the sustain portion of the signal's volume envelope. Increasing it will add more body, and decreasing it will reduce the sound's tail. Alright, let's move on to the feedback compressor. The feedback compressor compares the amplifier's output signal instead of the input signal to a threshold level. When the threshold is reached, the compressor reduces the signal's gain level. It's modeled after a classic feedback compressor known for its bright and punchy sound. High quality toggles oversampling, which increases audio quality but also increases CPU load. Stereo link makes the compressor act on left and right channels at the same time, preserving the stereo image. When disabled, the compressor acts like a dual mono processor, processing each channel independently. Input adjusts both the input level and threshold simultaneously. Increasing it will result in more compression. Alright, the solid bus compressor. This is a compressor modeled after the infamous SSL 4000 bus compressor. This is definitely one of my favorite effects and sounds amazing. It has the same controls as a standard compressor, but with makeup, mix, and a gain reduction meter. Compressor. This is your typical compressor with all the usual controls. The mode drop-down lets you choose between Classic, Enhanced, and Pro mode. Each of these modes provide a different flavor of compression, so you just need to try each one out with your sound to see which one sounds the best. Limiter. This is a type of compressor with the ratio set to 1 to infinity, threshold just below the maximum level, and a very short attack time, which is a typical limiter. The end gain sets the gain of the input signal. Adjust it until you see the attenuation meter responding to the occasional peaks. Tape saturator. This emulates soft compression and distortion of recording to tape. It can be used to add warmth, color sound, or add distortion. Gain controls the input gain. This increases the amount of tape distortion and compression. Warmth controls a low frequency boost or the cut of the effect. High frequency roll-off controls the high frequency roll-off starting frequency. Everything above this point will be attenuated. Distortion. This causes distortion by clipping or rounding off high sample values, simulating overloaded transistor or tube circuits. This adds artificial harmonics to a sound. The mode menu selects between tube or transistor. Tube distortion creates a smooth saturation with even harmonics, while transistor generates odd harmonics that creates a harsh sounding clipping effect. Drive adjusts the amount of distortion. Damping. To attenuate the high frequencies in the output signal, increase the damping. This counteracts the brightness caused by artificial harmonics. Lo-fi. This adds various digital artifacts like quantization noise or aliasing to a signal. Bits requantizes the signal to an adjustable bit depth. You can use fractions like 12.4 bits, which will add a ton of grit. Sample rate. This resamples a signal to an adjustable sample rate. The resampling is done without any low-pass filtering, which adds aliasing artifacts. The sample rate goes all down to 50 Hz. Noise. This adds hiss to the signal. Noise color. This adjusts the frequency characteristic of the noise and acts as a low-pass filter. Saturation. This is an amplifier with a non-linear characteristic. It allows you to recreate the effect of a tape saturation. The mode menu allows you to choose a saturation type. Classic is the original Kontakt algorithm. Enhanced is a higher quality saturation mode. And drums is a saturation mode used by a machine. Saturation adjusts the transfer curve. A negative setting results in a characteristic that will expand the signal. Lower sample values will be attenuated and higher values will be amplified. Positive settings do the opposite and simulate the compression-like saturation of an analog circuit. At 0, the signal will pass through the module unprocessed. Cabinet. This simulates the sound of a guitar cabinet recorded through a microphone. Placing this after a distortion effect will simulate a complete guitar amp. Cabinet type. This allows you to choose a simulated cabinet model with the up and down buttons. Size. This adjusts the size of a simulated cabinet. Larger cabinets have a more pronounced bass response, while smaller cabinets are thin and tinny. Air controls the level of early reflections in the room response, which adds a sense of space to the sound. Treble boosts or cuts the level of the higher frequencies. Bass boosts or cuts the level of the lower frequencies. Screamer is an alternate overdrive algorithm that is warmer and smoother than a distortion effect. Tone controls the brightness of the sound. Increase it for a more pronounced top end and decrease it for a mellower, darker sound. Bass adjusts the low frequency gain. Bright adjusts the high frequency gain. Clean, which is basically a dry or wet, adjusts the ratio between the clean and distorted tone. Twang. This simulates the classic guitar amp tube sound. Bright increases the high frequency content of the signal. Mono works just like the stereo link, except in reverse. When it's enabled, it sums the stereo signals to mono. Disabled works on each input channel separately. Volume controls the input level. Jump. This emulates a British guitar amp. It's great for creating smooth, ringing lead sounds and is available at the group and instrument level. High gain increases the preamp's gain. Use high gain if you want to create distorted or saturated sounds. Preamp sets the gain added by the preamp. Increasing it adds drive, distortion, and edge. Master adjusts the amp's master volume. Presence boosts the frequency response in the upper mid-range. Rotator. This simulates the sound of rotating speaker cabinets. Speed controls acceleration or braking of the rotor. It only has two positions, slow and fast. Acceleration and brake speed adjust how quickly the rotors of the treble and bass parts of the cabinet react to speed changes. At the rightmost position, the speaker will change its speed instantly. At the leftmost position, it will take a long time to reach its designated speed. Balance controls the relative levels of the cabinet's treble and bass parts. Distance controls the simulated distance between the cabinet and pickup microphone. Surround panner. Surround panner is an insert effect, and it can be inserted in the group insert effects, instrument buses, or insert effects. But because it needs to use a channel routing for it to work, it only makes sense to use it in the group insert effects. And to use our surround panner, we need a multi-channel channel. So let's go to our outputs and add a surround channel. I'm going to add a 5.1, which is basically 6 channels. Point it to the first input in logic. And now we have a 6-channel channel. Alright, the next thing that we need to do is we need to assign our instrument to this new channel. And now we can take a 2-channel sound and make it surround. Alright, so the surround panner provides surround mixing and automation capabilities to group signals. It allows you to place input signals on a spatial plane and move them manually or via automation, and simulate a range of natural dampening and Doppler effects, which occur when sound sources are being moved around the listener. The mode lets you select the output format. A complete list of all available surround formats along with their channel assignments is listed in the Kontakt 5 application reference. The channel mismatch indicator lights up when the sample and output don't have the same channel configuration. So this occurs if your instrument is only using 2 channels or your sample is only 2 channels. Mouse mode is a drop-down that lets you choose from a list of algorithms that affect how your input sources will be positioned on the plane and respond to mouse movements. With mono, all sound sources will be set to the same position. Sync. When a sound source is dragged, all other sound sources will move along in the same direction. Center mirror. The sound source positions will be mirrored at the center point of the plane. X mirror. Sound source positions will be mirrored along the x-axis. Y mirror. Sound source positions will be mirrored along the y-axis. XY mirror. Sound source positions will be mirrored along the x and y axis. And individual. Each source will be positioned individually with the mouse. And to show you how this affects mouse movement, if you click on one sound source, the second one moves with it when you're using X or Y. If you choose individual, you can move each sound source independently of one another. Algorithm. This determines how the level of a sound source will be affected by its distance from the center. Constant power panning algorithm will adjust the relative speaker levels of a sound source in a way that preserves the source's apparent volume regardless of its panning position. Placing a source icon right above a channel icon will isolate the source signal on the respective channel. Moving it around the plane will distribute its signal among the respective speakers in relation to their distance from the source, keeping the overall apparent volume, which is the power, constant. This is also affected by the divergence control. Sinusoid. This algorithm uses a sine function to adjust the volume of a source in relation to its distance from each speaker. Setting the divergence parameter to a lower value will result in a more directional image. If you move a source far away from the speakers and use a high divergence setting, its level can drop to silence. And finally, logarithmic. Logarithmic panning algorithm uses a logarithmic function to change the level of a source in relation to its distance from each other. Air absorption. This simulates the absorption effect of gradually losing high frequency as a sound source moves away from a listener. To increase the perceived distance further, even after dragging the sound all the way to the plane border, increase the size of the sound field with the size control to gain more space. Delay effect. When activated, sounds from sources which are further away from a listener will be delayed in relation to sounds nearby. Keep in mind this uses a ton of CPU. Also, if you want to simulate positioning entirely with delays and keep the levels constant, set the divergence to 0. Doppler effect. When activated, the surround panner simulates the pitch change when a sound source moves quickly toward or away from a listener. Options. This opens up a pop-up dialog which allows you to change the underlying parameters of Doppler, air absorption, and delay effects. You can also adjust the frequency of the LFE channel. The dialog also displays the number of input and output channels currently in use. The button labeled Out Routing will take you directly to the channel routing section of the amplifier module, where you can change the channel routings and create mix-up or mix-down configurations to convert between channel layouts. Divergence. This adjusts the amount of distance-dependent level changes and directional focus of sound sources on the surround plane. Setting the knob to 0 will result in constant levels regardless of positioning. Size adjusts the size of the surround plane. Turn the knob counterclockwise to zoom out. LFE adjusts the output level of the low frequency channel if the selected output configuration includes an LFE channel. X shift provides a constant offset in the X positions of all sound sources. Y shift provides a constant offset in the Y positions of all sound sources. Angle rotates all sound sources around the center point. Distance alters the sound source's distance to the surround system center from 0 to 100%. And the meter displays the output levels of all channels in the currently selected surround format. The surround panel can be automated by host or external MIDI controllers. X shift, Y shift, angle, and distance can be assigned. The surround panel also can be modulated using internal modulation. X shift, Y shift, angle, and distance can be modulated. Stereo modeler. This allows you to control the width of your signal stereo base, changing the panning and creating a pseudo-stereo signal from mono sources. Pseudo-stereo uses a pseudo-stereo algorithm to create a stereo signal from a mono source. Spread collapses or expands your signal stereo base. At the far left position, stereo signals will be summed to mono. Positive values will result in an artificial widening of stereo sources, but can expand past the speakers. So you have to be careful not to go too far with the spread. Inverter. This can invert the phase of your audio signal or swap the left and right channels. You should only use this as an insert effect. Phase inverts the signal phase polarity. Left-right swap swaps the stereo channels. Delay. This is a delay that can be tempo synced and provides an adjustable feedback level, low pass filter, and pan control for ping pong echoes. Time is the delay time in milliseconds. To synchronize to your host or master editor tempo, click on the speed parameters unit display and choose a note length value from the drop-down list. Damping attenuates high frequencies in the delayed signal. Increase it to increase the damping effect. Pan. Setting a value higher than 0 creates a ping pong delay. Higher values result in wider panning, and a value of 100 alternates signals between the far left and far right channels. Feedback controls the amount of the output signal being fed back into the input of the delay line. When delay is used as a send, the return knob is visible. This sets the effect mix going back to the main output. You can also control the output channel of the return. When used as an insert, you also get dry and wet sliders that adjust the levels of the original and processed signals. Chorus. This thickens the audio signal by splitting it up and detuning one version in relation to the original. Separate LFOs with an adjustable phase relationship detune each stereo channel independently for creating wide panorama effects. Depth adjusts the range of the modulating detuning. Higher values give a more pronounced chorusing effect. Speed adjusts the LFO speed. To synchronize the speed to your host or master editor tempo, click on the speed parameter unit display and choose a note length value from the drop-down list. Phase is 0 to 90 degrees and adds an LFO phase difference between the left and right stereo channel. This can increase the width of the output signal stereo base. This splits the audio signal up and delays one version in relation to the original signal. The flanger module also uses a separate LFO for each stereo channel. Color adjusts the delay line's range of operation and the color of the flanging effect. Feedback feeds a certain amount of the delayed signal back into the module's input. Phaser. This continually changes the phase relationship in your signal with an all-pass filter. The controls are the same as the flanger effect. Convolution is a reverb that uses impulse responses to replicate the acoustics of a specific room. The impulse window displays a currently loaded impulse response and volume envelope. You can drag IRs from the library into the window to load them. The row at the top displays the file name of the loaded IR, bit depth, sample rate, and the number of channels. Pre-delay introduces a short amount of delay between the direct signal and the convolution output. Latency adjusts the module's latency settings in 6 steps. Select a latency value of 0 for sample accurate timing. Sample rate allows you to divide a sample rate in 9 steps. If the preserve length button is not enabled, changing the sample merely changes the playback speed of the IR, resulting in longer reverb trails and change frequency characteristics. Activating preserve length will keep the reverb trail intact but lower sampling rate at which the convolution process takes place. This reduces CPU usage along with the quality. Reverse reverses the impulse response for special effects. Auto gain. If active, the processor will keep the overall level constant when parameters are adjusted that would otherwise affect the level. Be sure to monitor at low levels if you turn this off. Volume envelope allows you to change the volume characteristic of the IR by overlaying an adjustable 8-segment envelope on top of the waveform. Early, late. These mode buttons switch the 3 knobs below between affecting the early reflections and the trail part of the impulse response. IR size. This artificially compresses or stretches the IR in time. High pass. This adjusts the cutoff frequency below which the signal frequency's content will be attenuated. Low pass. This adjusts the cutoff frequency above which the signal's frequency content will be attenuated. Reverb. This simulates the natural reverberation that occurs when a sound source is placed in an acoustic environment. This adds a feeling of spaciousness to the sound. Size adjusts the size of the simulated room. This affects the duration of the reverb trail. Color allows you to adjust the construction material of the simulated room and the color of the reverb trail. Damping sets the amount of simulated absorption that takes place in the rooms due to furnishings, people, or acoustic treatments affecting the reflection behavior. Stereo. Higher values increase the stereo base width of your output signal. Lower values simulate a closer distance to the sound source. Gainer. This allows you to boost or attenuate the signal level between the previous stage's output and the next stage's input when used as an insert. When used as a send, it also allows you to send signals at an adjustable level to aux channels on a per group basis. Gain is an amplification or attenuation factor that will be applied to the signal in dBs. Send levels is a utility module that can be added to the group insert effects and instrument insert effects chains, and allows you to send a signal from within the insert chain to any existing send effect at an adjustable level. Levels on the left side is the level control for each send effect that's currently in one of your instrument send effect slot. The knob allows you to adjust the level of the signal sent to the respective effect. The level meters provide visual feedback on the send levels. Kontakt has a wide variety of effects modules that can be used to correct issues with your signal or for creative effect. Be sure to use the Modules tab of the browser to see descriptions of each module and their parameters. And don't forget to check out our website at www.kontakttutorials.com for more tutorials on Kontakt. ADSR Kontakt tutorials. Supercharge your Kontakt skills. This is DJ Nice signing off until next time. Now go make some music.